Morning students, in the previous video session you have gone through the particle moving in an inclined plane, and we have discussed in Zoom app class as well, and I believe that you all did your homework what I gave yesterday. And today let us see how these two mass of a body m1 and m2, this having different mass and which is kept in contact when we are applying the force on this, how this will move on this horizontal surface. That is what two bodies in contact on a horizontal surface. Let us see. You see here, you can see two object of mass m1 and m2, and here when we are comparing the mass of the object, here mass m1 is greater than m2. So mass m1 is greater than m2, so that what we can see is, assume that this is kept on a horizontal surface. It is a smooth surface, frictionless surface. Now applying a horizontal force. You see, I am applying a horizontal force, capital F, on this object. Now when we are applying a horizontal force on the object to the mass m1, now this what is happening means there will be acceleration in this direction. There will be acceleration. This mass m1 and m2 will move in the same direction. So this acceleration we can find out by using Newton's second law, F is equal to ma. F is equal to ma, and from this A is equal to, but here you have to write the direction also. Actually we are applying the force on x-axis. X-axis means you can use this is positive x-axis, so positive x-axis means use I unit vector, and because of that force, acceleration also in the same positive x-axis, so you use I unit vector. So F of I unit vector is equal to acceleration also in the same direction. Now comparing this component, we can cancel this I and I, and so that you can write F is equal to ma, and from this formula A is equal to F by m. Now we got acceleration, and here mass is what? We are using two mass, so that m is equal to m1 plus m2. So here two mass combined, so you can use m equal to m1 plus m2. So A is equal to F by m1 plus m2. This is what acceleration. This you can keep equation 1. Now we can find out the force exerting on this mass m1 and the force exerting on mass m2. You see here I am applying a horizontal force, capital F, on this. Now this m1 will come and hit this m2, so that what will happen means there is a force on this like this direction. There is a force on mass 2 because of 1. Because of this mass 1. When you are applying a force here, this mass m1 will come and hit here. So there is a force on this mass 2 due to the force exerted by mass m1. At the same thing, according to Newton's law, Newton's third law, for every action there is an equal and opposite reaction. If there is an action like this, there must be a opposite reaction. So the same mass m2 will exert a force on m1 also. So a force exerted on 1 due to the mass m2. So F12. Now we have to find out this F12 and F21. For that we can draw a free body diagram separately. So you see, this is a horizontal surface, and this is a mass m1, and here I am applying the force capital F and M1. Okay, you know that in M1 force direction is this. So F12. Now we can apply the Newton's law. F is equal to Newton's second law. F is equal to ma. Now the total force is what are? This direction capital F, this direction F12, and this is what we are saying. Here there is a force, no? In this there is a force exerted by the block M1 on M2. There is a force exerted by this block M1 on this M2 due to this motion. So what is happening means this force we can tell that contact force. And here let us see, we have to find out this net force. What is the net force? So net force F is equal to this direction F. So this direction means this is positive x direction and this is in negative x direction. Positive x means I unit vector plus I unit vector, negative x means minus I unit vector. Now you see I am applying the total force F into plus I unit vector, net force is plus F12 minus I unit vector equal to acceleration, where acceleration is this direction. This is positive x axis, so I. So mass into acceleration I direction. Now you see, you can write this equation F of F I unit vector plus F small f 1 2. So I am writing here this equation. I am writing how F I unit vector, then minus, this minus will come here, so that minus F12 I unit vector equal to MA I unit vector. So this is the equation, and here mass is M1. Here mass is what? M1. Now you see, from this comparing the component, and comparing the component means we have to remove all these I. So F minus F12 is equal to M1A. Now from this we can find out this force exerted on this mass M1. So minus F12 is equal to M1A. So sorry, minus F12 is equal to this F, take this side, so minus F plus M1A. Now you can change this minus by F12 is equal to capital F minus M1A will come. Now you see F12 is equal to F minus M1 into A is what? From equation 1, A is equal to F by M1 plus M2. So F by M1 plus M2. Now F12 is equal to, here F, multiply this M1 inside, minus M1 F by M1 plus M2. Now take this F outside, so F12 is equal to capital F I am taking outside, 1 minus M1 by M1 plus M2. Now this M1 plus M2 is the LCM, here you substitute. So what will come? F12 is equal to F into M1, taking the LCM, that is what? Plus M2 minus M1 divided by M1 plus M2. Okay, now M1 plus M1 minus M1 cancel, so F12 is equal to F into M2 by M1 plus M2. So now we got Fm2 is equal to M1 plus M2, that is what? The force which is exerted on the mass M2 M1 due to this mass M2. Now this is the equation. Actually this force is acting in the direction. This force is acting in the direction negative x direction. So you can write this equation in vector form. While we are writing this equation in vector notation, what we will get means we will get in vector notation we can write that equation F12 vector is equal to Fm2 by M1 plus M2. Fm2 by M1 plus M2. So you have to use, I told this F12 is acting in the direction negative x direction, so you can put the vector for direction minus I unit vector. So F vector 12 you can write minus F M2 by M1 plus M2. Okay. Now the same thing, this is what we have found. What we found? When we are applying this force, this mass M1 is exerting force on M2. The M2 is exerting force on M2 we find out. Now we can find out how much force is exerted on this mass 2 because of mass M1. So now you can draw diagram. Here you have to draw the free body diagram also for this. So it will be like this. This is a mass, and this direction force, this direction, and opposite what? F12, opposite F12, downward mg, upward normal force. This is a free body diagram for mass M1. Okay, now we are finding the second thing. Second thing is what? This is a diagram. This mass M2, here the force is acting, and the F21 also in the same direction, capital F also in the same direction. So we can draw the diagram. So this capital F no need, just you can take this mass. Okay, you see, small mass M2, and here acting the force is F21, force on 2 due to what? This one. So if you are drawing the free body diagram, mass, force this direction is mg, this direction is normal force. This is a free body diagram, and we can find the equation. So if the same Newton's law we can apply, F21, this is in the direction of positive x-axis, so you can use plus I unit vector. The same, F is equal to ma only, Newton's second law formula, so F is equal to m into acceleration. Acceleration also in the same direction, here mass 2, acceleration also in the positive x-axis, so I unit vector. So F21 is equal to m2 a I unit vector. Here also unit vector. Now comparing the component, so this I no need. F21 is equal to m2 a. What is this a? A is equal to, we have found already, F by m1 plus m2. F by m1 plus m2. So F2 is equal to m2 into a value is F by m1 plus m2. So you can write this F21 is equal to F m2 by m1 plus m2, and in vector notation also we can write the same thing only, because you see vector notation also, this force is acting in the same positive x direction, so F vector 21 is equal to F m2 by m1 plus m2 into I unit vector. Now you see what is happened. By this we can confirm the Newton's third law. Actually Newton's third law is every action there is an equal and opposite reaction, and he said this thing only, F12 is equal to minus F21. This we are proving through this derivation. This is what Newton's third law said. If force exerted on the object 1 or due to this 2 is equal to the force exerted on 2 due to the object 1. So here this is what, every action there is an equal and opposite reaction. So if you are comparing these two equations, you see first we got minus Fm2 by m1 plus m2. F12 equal to what we got, the same, Fm2 by m1 plus m2, but here minus. So that is what here proving through this Newton's third law as well. So you can go through this derivation. So again I will tell you a glance for it. So first thing, we are keeping two mass m1 and m2 on a horizontal frictionless surface, and when you are applying this mass m1 is greater, m2 is smaller. Now you are applying a force on this, a horizontal force is applying on this. While applying a horizontal force on this mass m1, this mass m1 will exert a force on this mass m2 in this direction, as well as this mass m2 is exerting a force on this mass m1 in this direction. So the total acceleration, the both will move in this direction only, but this mass m1 and m2 will exert a force to each other. Now you see here F is equal to ma, we are taking the equation F is equal to ma. We are applying the Newton's second law on this full diagram. So force is in this direction and acceleration this direction, both are in the positive x-axis. So I unit vector we are using. While comparing that, I will go, so A is equal to F by M, and M is what, now together moving, So that is what m1 plus m2 we are putting. Now we are finding, we are applying the Newton's law on only mass m1. So m1, this direction capital F, and opposite the f12 is there. This direction is positive x, so plus I, and opposite is minus x, so minus I. And the net force is F of I, plus we are adding these two force, and next step of this minus will come here, and acceleration I only, so that we will get this equation. Now we are comparing the component, so we are removing all I, so we are writing the same equation. Then we are finding minus f12, so the step and all substitute, what are addition subtraction only, we are changing the minus, we are multiplying by minus, so inside a minus will come. Next step, instead of A we are applying what are this value F by m1 plus m2. Then we got multiplying this m1 inside, so you will get this equation. Now F is common both sides, so taking the F outside, so here 1 will come, 1 minus m1 by m1 plus m2 will come. Now I am taking the LCM, this m1 m2 I am substituting here, so that plus m1 minus m1 cancel, we will get only m2 inside, outside F, so F m2 by m1 plus m2. Next is we are writing the same equation in vector notation, and this f12 is acting opposite direction, so minus I we are using, here we are putting minus. At the same time for the mass m2 also, you know this mass m2 it is acting f21, and this acceleration, so you see f21, this direction it is acting, acceleration also same direction only. So comparing the component, removing A, so we are substituting A value, so we will get. Finally we will write this according to Newton's third law, no, f12 is equal to minus f21. So my dear students, all of you go through this derivation. This is also another 5-mark question, important 5-mark question from this unit. If you need, you can take a screenshot of this, and you can study this. Okay, so thank you all, bye bye.